Hello, it's Scott Manley here. Now, today I have something very much different from my usual video game, science-y type stuff. This is essentially a video version of a presentation that I've given at a couple of different events, where I've essentially been talking about the educational qualities of Kerbal Space Program, trying to explain Kerbal Space Program to scientists or teachers or parents. Why do I think the game is great as an educational tool? What makes it different? And I think I wanted to basically put down on video what I've been pitching and what I've been sharing, because maybe you want to show this video to someone else who's perhaps skeptical about the notion of what you can learn. So yes, Kerbal Space Program. Can a game really teach you rocket science? And as a proponent of the game, I would say yes. Of course, I am biased, but just because I'm biased doesn't mean I'm wrong. And I'm going to try and make my case over the next 20 minutes or so. Now, the game title is Kerbal Space Program. What is a Kerbal? A Kerbal is a little green man. And here we have the original three Kerbinauts. In the middle we have Jebediah Kerman, Thrill Master Extraordinaire, always excited to going flying in a rocket. On the right we have Bill Kerman, who, he's too stupid to be afraid of rockets. And on the left we have Bob. Bob is smart enough to understand the dangers he's about to face and lacks the courage to face it with anything but a look of terror. And I should point out that since I wrote this talk, Valentina Kerman, the first female Kerbinaut, has been added to the ranks, and she is smarter and braver than all of them. As for me, well, I'm Scott Manley. I grew up in Scotland, I studied physics and astronomy, I have a day job as a software developer, I make videos on YouTube, which you're watching one off right now, obviously. 500,000 subscribers, whoa, good lord, that's a big number. And I didn't plan any of this just kind of happened randomly. But we're here to talk about the game. Kerbal Space Program was developed by a guy called Felipe and a company called Squad. The first release was in June of 2011 when I found it. It was finally released as a 1.0 in April 2015, and the most recent version is 1.1.2. They've sold over 1 million copies, I hear, but that's entirely an estimate. But funnily enough, this wasn't really planned. The company that makes the game isn't actually in the business of making games, or wasn't in the business of making games when they started making it. And indeed, they've recruited people from all over the world. People have come and gone as the project has moved on. And this is a selection of characters from various points in the development of the game. Not all of these people are still working on the game, but there's Felipe up the top. He's the original person that had the idea, that delivered the ultimatum that said, I want to make a game, please let me. Now, Kerbal Space Program, in a nutshell, you bolt parts together to build a rocket, or an aircraft, or a boat, or whatever. You then unleash the laws of physics and attempt to fly your creations. You have a whole star system to explore, and optionally you can unlock better rocket parts by exploring, but failure is always an option. In fact, failure can sometimes be the best part. While the game is called Kerbal Space Program, you can literally build any kind of vehicle that obeys the laws of physics, and people do build completely crazy things, such as this boat that flies in space. Like some kind of space boat, or maybe space ship. People have built race cars, giant walking robots, rocket-powered lawn chairs. Yeah, rocket-powered lawn chairs, can you believe? Crazy idea, but it turns out that reality isn't too far away. This one on the left is obviously in Kerbal Space Program. That one on the right, that was actually a concept that was designed and investigated by NASA. Did you know that NASA actually invented the Wii balance board? Because they wanted to figure out if a pilot could control a spacecraft by leaning left and right. This is called the LESS, the Lunar Escape System. I'm not sure why there's two S's, but NASA does like its acronyms. This was investigated in the 1960s as part of the Apollo program because, of course, if your people got stranded on the moon, you'd like some way to bring them back. And similarly, there was something with the delightful acronym of MOOSE, Man Out of Space Easiest. Not Man Out of Space Safest, or Man out of space most comfortably. No, in this case an astronaut would jump out of his spacecraft which was in trouble and couldn't deorbit. He would have a foam heat shield he would inflate, and then a handheld rocket that he would use to deorbit himself and then land on a parachute. Yes. I mean, I guess this does sound like a better option than, say, suffocating in space. But coming up with crazy rocket technology wasn't just the remit of NASA. Private citizens actually came up with some really interesting ideas, such as the rocket catcher, a device designed to catch rockets. I have no idea how this was supposed to work, but somebody apparently patented it. And you know what? People have tried to build these in Kerbal Space Program because Kerbal Space Program lends itself to crazy crackpot schemes. Okay, so let's talk about Kerbal Space Program and the technology underlying it. It's built on Unity, which is a pretty popular game engine, and rockets are essentially modelled as a series of interconnected parts, such as engines, fuel tanks, command pods. Now, each part has like motion and rotation and mass, and each part is individually subject to the forces of gravity, thrust, aerodynamics, the forces between joints, the forces from impacts, and also between them you will have flows such as fuel or electricity or even life support in some cases. Now your rocket, when it's hit, parts of it can break off, so the joints between those parts can break. And you'd be surprised how often this rapid unplanned disassembly actually happens. In fact, it'll generally happen so often that you will become quite comfortable with it and, well, essentially not panic when things go wrong. To the untrained eye, this situation may look rather dramatic and dangerous, and it is, it's not an ideal outcome. But the Kerbals in this situation will quite possibly survive if the pilot keeps their head. But how do you learn to keep your head while all around are losing theirs? Well, it's all about practice. It's all about what I call the Kerbal feedback loop. That's essentially a process of experimentation. You build the rocket, you fly the rocket, and then things don't quite work. So you fix the problems and then you go back to one, right? And this is what Kerbal Space Program really is all about. It's about giving you an ability or a place where you can try to do something, get experience with scenarios which you would really not ever encounter in everyday life. And you know, really this is how a lot of learning actually happens in real life. How do you become a good driver? You become a good driver by driving, and you probably make mistakes on your way to becoming a better driver. You know, anybody can get experience driving a car, but how many people can get experience flying a rocket? A rocket that they designed. This is from XKCD, and it really boils down for me what a Kerbal Space Program really does well. It lets you experience things, and by letting you experience things, it massively increases your understanding of it, just simply due to the natural feedback you'll get through having to be good at the game. But look at this, you know, there's 4 different things in this graph, and your average 10-year-old will only have done one thing. They'll have started playing Kerbal Space Program, and that's the thing that gives them the most understanding, because it's an interactive experience. It's an experience where you can learn from your mistakes. So for example, here's a few things that can happen. You might build a rocket that doesn't have a high enough thrust to weight ratio, and your rocket stays on the pad. So what do? You add boosters. If your thrust to weight ratio is too high, then your rocket might break up because it's going too fast, so you add struts instead of, say, dialing back the thrust. You might launch a probe and it'll run out of power. Well, you learn that you need to bring solar panels next time. You might get to the moon and have a hard landing because you didn't have enough fuel, so it's time to send a rescue mission. You might encounter aerodynamic instability and need to adjust the aerodynamics, or you might not be able to dock, at which point you will probably try to learn to fly in space. Now, of course, if you're an actual rocket scientist, all of this will probably seem really obvious, but you have to remember that the pioneers of the field, you know, they didn't magically learn all of this stuff. They had preconceived notions, which some of them turned out to be completely false, such as Robert Goddard here, pictured next to one of his liquid-fueled rocket designs. Now, Robert was great at building these engines. He didn't know so much about steering these things, and he had the bright idea that if he put the rocket engine at the very top and pipe fuel up to it, then the whole thing would kind of hang down and be stable. This is called the pendulum rocket effect. Turns out it's complete rubbish, and this thing, of course, when it took off, eventually flew over and crashed into the ground. And that's something you would learn if you experimented with this design in Kerbal Space Program. Back in the 60s, you had the Gemini missions. This is the crew of Gemini 4, McDivitt and White. They were supposed to perform the first rendezvous in space. After detaching from their upper stage booster, they were supposed to turn around and fly up close to it just to get some idea of docking. Instead, they spent 2 hours going around in circles, unable to get close to it because they didn't understand orbital dynamics. They were the best pilots in the world. They were amazing, and yet they didn't understand orbital mechanics. I mean, they probably understood it on paper, but they hadn't had any experience of flying around in orbit, and therefore when they accelerated towards their target, they ended up going underneath it and then going away from it. It got very confusing. The Gemini program ended up getting help from some guy called Buzz Aldrin that happened to be an expert in orbital rendezvous. And my point here is that I know 8-year-old kids that can now perform this maneuver because of Kerbal Space Program, not because they were smarter or better than these pilots, but because Kerbal Space Program gave them an environment in which they could learn this and experience it and figure out how orbits actually work. But in perhaps a more academic way, you can also learn things. For example, Newton's second law, which is stated as force is equal to mass times acceleration. But if you are a rocket sitting on a pad, what you really care about is that your acceleration has to be higher than the force of gravity. Therefore, the engine thrust you need to leave the pad is equal to the rocket mass times the acceleration due to gravity. That's a really simple equation that you very, very quickly learn because otherwise your rocket doesn't go anywhere. But you know, if you really want, you can get into more complicated equations such as Tsiolkovsky's rocket equation, which essentially tells you once you're in space, how far can you go? But actually in space, how far you can go depends upon how fast you can go. So, you can compute your delta V, which is a complicated mathematical term, which actually is very useful in Kerbal Space Program. You want to make sure your rocket has enough of it, and what you just do is you multiply a bunch of numbers together and then take a logarithm. Or you can just rely on one of the built-in mods to do it for you. And then once you have your delta V, there are people that have compiled nice little maps. These are not maps of routes, these are maps of delta V requirements, of the velocity you need to go from the surface of Kerbin to the orbit of Kerbin, and then to leave the orbit of Kerbin and perhaps fly to another planet such as Eve or Duna. And of course, this is a very simple tool, and if you really want, you can actually apply super high quality NASA spacecraft management tools to the Kerbin system and figure out exactly what kind of routes you're going to take. But this represents way more planning than many players like to do. They like to mess around with their orbits in-game. And for that, there is an experimental tool called maneuver nodes. This is a great idea that came from Kerbal Space Program. In the game, on the map, you can see the trajectories being plotted forward in time. And you can see where they pass close to other planets. You can see an instant update on these when you fire your engines. But maneuver nodes, these let you ask hypothetical what if questions. What if I fired my engines here? So you can set up a maneuver someplace, find out what happens, and maybe adjust the relative velocities. And by doing that, you can set up a course for your spacecraft. And you still have to fly it manually, you have to perform the maneuvers yourself, but the great thing is it just lets you experiment, and you can find out that there's certain places where it's much better to perform a maneuver. For example, you can fire your engines when you're closest to the planet and moving fast as possible to take advantage of something we call the Oberth effect. So this is another example of the ability to experiment being the main way you learn in Kerbal Space Program. Anyway, the Kerbin universe is a lot smaller than the real universe, and this was for technical reasons related to the precision of mathematical operations. That meant that essentially Kerbin is 1/10 of the size of Earth. But as it happens, I think that made the game a lot more accessible. It meant that if you were trying to get two spacecraft close to each other in space, it was a whole lot easier because space was a whole lot smaller. It meant that it takes a lot less time to get into orbit and a lot less time to come back from orbit. It's essentially the important things don't take so long that you're getting bored. And that's not to say there aren't operations that take a really long time, but we do have time acceleration to take away the tedium. But I studied orbital mechanics at college, and so I didn't learn much of that in Kerbal Space Program. What I did really learn about is aerodynamics. One of the first things that people learn in the game is that a nose-heavy plane flies poorly, but a tail-heavy plane flies once and tends to then crash immediately afterwards. The second thing they learn is that burning fuel can sometimes make your plane tail-heavy. Building an aircraft is actually vastly more complicated and difficult than it is to build a rocket in Kerbal Space Program. It does actually model aerodynamics. They use a very kind of primitive aerodynamic system because they have to calculate it in real time. But of course, this would be the state of the art in the 1960s. They use approximate cubes for chunks of the body, and they have wings that produce lift based on the angle of attack, and they have some sort of Mach effects. There's body lift that's in there, and they also have to model the effects of shock heating. That's essentially when you're going super fast through the atmosphere, you have a chance of burning up, or more likely some critical bit of your aircraft will burn up and then the rest of it will disintegrate as your spacecraft falls apart. And that really brings me to, what I get asked all the time. How realistic is it? Well, honestly, gameplay wins whenever there's a question. The ion engines in the game are incredibly powerful because players would not be patient enough to wait weeks. Nuclear engines are balanced around being a good gameplay thing, so they're weak, but they offer high specific impulse and they don't irradiate your crew. Engines tend to be very heavy because the delta V requirements from the small planet. The engines always start and they throttle from 0 to 100%. You have a limited set of fuel choices. You don't have to worry about the fuel evaporating or freezing, and you never have to worry about fuel flow being restricted by the size of the pipe. There's technical limitations to the game. There's no implementation of life support. The communications always work, assuming that you have power. There's no problems with the speed of light. And for orbital mechanics, they only ever model one gravitating body at a time. That means there's no Lagrange points, it means there's no halo orbit, and if you're a pro in orbital mechanics, that may sound like quite a restriction, but I should point out that NASA used this same level of approximation when they put men on the moon. So the game is designed to be fun rather than realistic. But what happens if you want real hardcore realism? It turns out there's a ton of people that have been working on this. There are mods that you can get and download. You get Ferrum has improved aerodynamics, we have life support, communications, a realistic scaled solar system, every kind of fuel you could ever need, better re-entry, engine igniter issues, and you have an autopilot. And somebody actually has worked on a pretty good implementation of n-body gravitational effects. You can make the game as complicated as you like. And all these mods are essentially free add-ons from members of the community. So I just want to talk about what I've learned, and one of the biggest things I have learned from Kerbal Space Program is that manually piloting a spacecraft is possible. In fact, it's actually quite easy if you have the correct instrumentation. I always thought that flying a spacecraft was always done by computers. If you have the instrumentation, you can do it manually. I also have found out that crazy spacecraft designs actually have a basis in reality. If you come up with a crazy idea, NASA's probably already looked at it. I've also found out that every mistake that a player can make in the game actually has had a real-world analog, a real-world disaster caused by the same things. But the best thing, the most amazing thing that I've learned is that given this environment, given the time and the energy, kids can learn anything. They can learn stuff that took me years of college to figure out. Not because they are poring over equations and solving them in textbooks. It's because they're experiencing the effects of the physics in a simulation where they can actually have fun. It certainly doesn't prepare them to take an exam in astrodynamics, but it puts them in a really good footing to give them a solid understanding of what's really going on and how things behave. And that for me is the most amazing thing about Kerbal Space Program. But I should step back and say it's not just Kerbal Space Program. There are other games which can give people very similar skills, very similar experiences. There's Orbiter 2010, which is a free realistic space sim. I mean, some of the modules actually emulate practically every switch on control panels of the lunar module, if you want to get into that level of detail. Space Engine is great because it lets you actually explore a virtual universe completely free. Universe Sandbox is a fun orbital mechanics simulator which lets you, put planetary systems together and then perhaps bombard your creations with asteroids, causing apocalypse for their inhabitants. And if you don't have a PC, I would like to point out Simple Rockets. It's like a two-dimensional version of Kerbal Space Program that runs on iOS or Android tablets. It's a nice little thing to do. You can fly rockets while you're on the train. They also have Simple Planes is from the same author, which lets you build aircraft. It looks a lot nicer and is a lot of fun. And of course, if you don't have a PC, but you do have an Xbox One or a PlayStation 4, we've seen Kerbal Space Program is going to be coming to these platforms in the future, so just because you have a games console doesn't mean you can't play Kerbal Space Program and learn things. So I hope you found that interesting. I'm Scott Manley. Fly safe.